Solar panel efficiency versus fill factor, and why both matters when choosing a good solar panel. A lot of people buy solar panels by looking at only one thing, the wattage. They hear 500 watts panel and think this one must be powerful and very strong. It will power all my house and charge my battery full. Not always, my brother. Two solar panels can both be 500 watts, yet one can be clearly better than the other. Why? Because wattage alone does not tell the full story. If you really want to understand whether a solar panel is good, you need to understand two important factors. The first one, the efficiency, and the second one, the fill factor, which is also called the FF. These two are very important because they help you know, one, how well the panel turns sunlight into electricity. Two, how strong and stable the electrical output is. Three, how well the panel is designed internally. And four, whether the panel is likely to perform better in real life. So in this video, I will explain the difference between solar panel efficiency and fill factor in a very simple way, using a 500 watt solar panel as our base example. So sit back and relax while you enjoy this very educative course. What is solar panel efficiency? Solar panel efficiency simply means how much of the sunlight falling on the panel is converted into usable electrical power. That is all. The sun sends energy, the irradiance, onto the panel, and the panel does not convert all the irradiance into electricity. Some are lost due to heat, some are reflected, and some are wasted simply because of the material limitation of the panel. So efficiency tells us how much of that sunlight was actually turned into power. Simple definition now. If sunlight hits a panel with a certain amount of energy and the panel converts a good portion of heat into electricity, that panel has high efficiency. If it converts less, then we can say the panel has a lower efficiency. Simple example of efficiency with a 500 watt panel. Let us use a 500 watt solar panel. Under standard test conditions, solar irradiance is taken as 1000 watts of sunlight per square meter. Now imagine your 500 watt panel has a physical size of, let's say, about 2.2 square meters. That means the sunlight energy falling on the panel is 1000 times 2.2. That equals to 2200 watts of solar energy. But the panel only produces 500 watts of electrical power. So the efficiency equals to output power divided by input solar power times 100%. So to calculate this, efficiency equals to 500 divided by 2200 times 100. We get 22.7%. This means the panel converts about 22.7% of the sunlight falling on it into electricity. That is a strong efficiency level for a modern panel. Why efficiency matters? Efficiency matters because it affects how much power you can get from a limited space. For example, if your roof is small, a high efficiency panel helps you get more power from that small area. If two panels are both 500 watts, the more efficient one is usually smaller or better at converting light into power. So higher efficiency often reflects better cell technology. In practical terms, a high efficiency panel means more power per square meter, better use of roof space, often better modern design, usually more premium technology. This is why efficiency is a big deal, especially for homes, offices, shops, and anywhere you are, you might need your solar installation. What is fill factor now? Now let's talk about fill factor, or FF. This is where people get confused because efficiency and fill factors are related, but they are not the same thing. Simple meaning of fill factor. Fill factor tells you how well the solar cell converts its voltage and current into maximum usable power. It shows how square and strong the electrical output of the solar panel is. A panel may have decent voltage and decent current, which are the VOC and the ISC. But if the internal electrical behavior is poor, it may not deliver power efficiently at its best operating point. That is where FF comes in. Very simple way to think about it. Imagine you are carrying a bucket of water that you have just picked up from the rain. Like the water is maybe half full. Efficiency is the water you have collected that is half full. Now the fill factor is the likelihood of you carrying that full bucket of water into the house without spilling. So efficiency is about converting sunlight into electricity, while fill factor is about how well the panel's voltage and current combine to deliver strong usable power. The formula for fill factor, the formula is simple. FF equals to the P maximum divided by VOC times ISC, where the P max equals to the maximum power of the panel. That's the provided wattage, which is the 500 watts that is written on your panel. The VOC is the open circuit voltage, and the ISC, the short circuit voltage. These values you can find on your panel nameplate. What these terms mean in plain language: the VOC, this is the maximum voltage the panel can produce when it is not connected to any load, and the ISC, the short circuit current, is the maximum current the panel can produce when its terminals are short circuited. That's when you connect the positive and negative end of your terminal. And the Pmax, this is the actual maximum usable power that the panel produces at its best working point. Now, if a panel's voltage and current were used perfectly, then the product of VOC and ASC would match usable power closely. But in real life, that does not happen because of losses, because of reflection, and every other thing that we might consider. So, fill factor tells you how close the panel gets to its ideal electrical rectangle. Example of fill factor using a 500 watt panel. Let's assume that the 500 watt panel we are talking about has a VOC of 49.5 volts and 13.5 amps with a P max of 500 watts. Now let's calculate the VOC times ISC. So 49.5 times 13.5 equals to 668.25. Now divide P max by that value. So FF equals to 500 divided by 668.25. So we'll be getting about 0.75. That's 75%. This is a decent fill factor. What does this mean? It means the panel is able to convert about 75% of its theoretical voltage current rectangle into real maximum power. The higher the FF, the better the internal electrical quality of the panel. Using our previous example of you carrying rainwater, that means you are able to carry 75% of the rainwater in the bucket while spilling only 25%. That is what this calculation entails. Why fill factor matters? Many people ignore FF because it is not as commonly advertised as the wattage or efficiency. But FF also matters a lot because it tells you how healthy and well built the solar panels are, especially the solar cells. A good fill factor usually means lower internal resistance, better cell quality, better electrical contact, less wastage power inside the cell, stronger power delivery, and when we consider the opposite, which is a poor fill factor, it means losses due to bad materials, poor manufacturing quality, poor internal design, more electrical resistance, and weaker performance. So while efficiency tells you how much sunlight became the electricity, FF tells you how clean and effective that electrical conversion is internally. Difference between efficiency and FF. Let us make the difference very clear. Efficiency is about sunlight in, electricity out. It measures how much solar energy falling on the panel becomes usable electrical power, while the fill factor is about how good the panel voltage current relationship is. It measures how well the panel's electrical characteristics combine to provide strong maximum power. In one sentence, efficiency looks at the panel from the outside, while fill factor looks at the panel's electrical quality inwardly. Can a panel have high efficiency but poor fill factor? It can happen. Though in quality panels, good efficiency and good FF often go together. A panel might use good light absorbing technology, which helps efficiency, but still suffer losses because of poor contact, internal resistance, low quality soldering, weak cell connections, and defects in maybe one or multiple of the cells, that can reduce the FF. So when both efficiency and FF are high, that is usually a stronger sign of a truly good solar panel. So what are good values for efficiency and FF? For efficiency, modern good solar panels often fall around 18% to 20% decent, 20% to 22% very good, and 22% and above excellent or premium. For a 500-watt panel, if it is physically smaller but still gives 500 watts, that usually suggests higher efficiency. For few factors, typical FF values are often around 70% to 75% okay to good, 75% to 80% very good, 80% and above excellent, especially at cell level. In commercial panel models, FF is usually lower than ideal laboratory cells because module construction adds more to the losses. How it affects efficiency and fill factor. This is another very important issue. In real life, solar panels get hot and it affects performance. What happens in it? As panel temperature rises, the voltage drops, efficiency drops, and the FA follows suit. That means a panel may be rated 500 watts in factory, but under hot sun, it may perform lower. This is why higher quality materials matter. Better panel technology can reduce heat-related losses. Some advanced technologies like HJT often handle temperature better. So, when choosing a panel, do not only ask how many watts, also ask how well does it perform under it. How to spot a good panel in real life. When choosing a solar panel, look at these few things. The wattage, yes, it matters, but do not stop there. Check the efficiency. Higher efficiency usually means better use of space and better technology. Check the fill factor. A stronger FF means better internal electrical quality. 4. Check the cell type. Monocrystalline is usually better than polycrystalline. 5. Technological type. Look out for panels that are PERC, TopCon, and HJT. 6. Temperature coefficient. Lower temperature losses are better. 7. Warranty and degradation rate. A panel that stays strong for many years is better value. 8. Brand quality and manufacturing consistency. A poor manufacturer can ruin good materials with bad production. In conclusion, when people buy solar panels, they often focus only on watts, but watts alone do not tell the full story. If you want to understand whether a solar panel is truly good, especially a 500-watt solar panel, you need to pay attention to two deeper measures: efficiency and the fill factor. Efficiency tells you how much sunlight the panel converts into electricity. The fill factor tells you how strong and clean the panel's internal electrical performance is. And both of these depends heavily on the silicon quality, the cell design, the pervasion technology, the electrical contact, the internal resistance, and the manufacturing quality. So the best solar panel is not just the one with a high watt number. It is the one that combines strong efficiency, strong fill factor, quality materials, good heat behavior, and reliable long-term performance. That is how you judge a good panel properly. I hope this extensive course you have been able to understand how to spot a good solar panel. Thanks for watching. To like, share,